Welcome to RF lecture series. In this lecture series, we'll discuss about the phase lock loop. Phase lock loop. A phase lock loop is a feedback system combining a voltage control oscillator and a phase comparator. So they connected that the oscillator maintains a constant phase angle related to the reference phase angle. Why we use the phase lock loop? Because the voltage control oscillator will not generate a stabilized voltage. So why it occurs is due to the thermal and the outside the noise. So the phase lock loop have a system where it maintains the constant voltage in all the frequencies. So phase lock loop can be used for example to generate a stabilized output high frequency signal from a fixed low frequency signal. Before going to the structure, let us explain the concept of the phase lock loop. So here, let us imagine there is a two frequencies of F1 and F2. So here we have to find F1 and F2. So we have to see when the phase between the signals changes, it means that they have a different frequency. So it depends upon the phase changes of a signal. So when the phases changes, then we have a different frequency. Whereas when the phase difference remains the constant, then frequencies are equal. So here we have to check the phase difference between these two signals. So here you can see we have the phase differences. That means that the frequency is not equal. And here you can see the phase differences are same. So the frequencies are in equals. So we have to check the signals with respect to the time. Based on the time to time interval, we have to check the frequencies of this signal. So when this frequencies remain constant, then the phase remains constant, then the the frequencies are same. When the phase is keep on changing with respect to this time, then we have the different frequencies. So next we'll see the how PLL is working. Before going to this how PLL work, we'll see this why do we need a PLL. So we have seen this is the mixer block. Here in mixer we need an input signal and we have the local oscillator where it generates the high frequency of cosine signal, and this local oscillator is nothing but the voltage control oscillator VC. That VC will not produce the constant voltage. Whatever the frequency, that frequency will be in the unstable form. So to make the VC to be stabilized form, we need a high frequency of carrier. So VC cannot produce the stable high frequencies. So why VC cannot able to produce the stable high frequencies? Because it is affected by the temperature and noise, as I told already. I have told it. So we need a reference oscillator with stable frequency. So with this reference oscillator, we are forcing this VC to follow that references. For example, we say this reference oscillator, so we can say it is like a master thing. Master, and this VC will act like a slave. So here in many cases, this VC will produce the stable frequencies. So normally many people will ask this why instead of using this local oscillator, we can go for the reference oscillator. But we cannot use the reference oscillator because this reference oscillator will produce only the low frequency with the stable, whereas this VC will produce the high frequency with unstable form. So what we are doing is we are forcing this VC to produce the high frequency to produce a low high frequency with respect to this reference oscillator. So this is the reason why we go for this PLL. So the PLL will have the proper systematic approach to convert from this unstable VC to this stable frequency with respect to the reference oscillator. And now we'll see this how the PLL will work. And here we have seen this PLL voltage VCO will not have the stable output, stable voltage. So there will be have some instability in the voltage. So what we are doing this, and this reference voltage which has a low voltage but it in the stable condition. So for example, if this reference voltage have the frequency of 2 megahertz and this output or this VCO will have the, for example, it is considered of 2 gigahertz. Okay, let us see, let's consider take the 3 gigahertz, and here is also 3 megahertz or something for example, for understanding purpose. So this 3 gigahertz frequency, when I are giving output of this, it will not be in the stereo. So what is it when it comes to the now output string, that this frequency will get increase or else it decrease. So for example, when it will be in the concentration of 3.1 gigahertz, what this frequency divider will do is, this frequency divider will divide the frequency of 3.1 gigahertz till it reaches the meet the reference voltage frequency. So that is of 3 megahertz. So after meeting this reference voltage frequency, then it will give to the phase detector. So this phase detector will detect the phases, how the signal, what type of phase, whether the phase will be the same or else the phase will be the difference voltage. So after detecting this phase voltage, so this phase is given to this amplifier and then to the filter. Now this phase frequency will convert the phases to the voltage. So what happens based on this? So now it is convert the from phase to the voltage. So the changes is happening from the phase signal to the voltage signal. So here based on this voltage, now this VCO will become the stable. So when we increase the frequency, the voltage we have has to be, the VCO will have should be the low voltage, and when we decrease the frequency, the VCO will be in the high voltage. So as per this understanding of this PLL is little bit complicated, but it is an important block of this transceiver system. And here I'll explain in this graph. Here you can see this is the F1 is the reference frequency which is generated by the VCO, and this is the feedback which is generated by this frequency divider. So it is given this, and here this phase detector will detect the frequency. Here this phase detector will detect the phases. So based on this, if the phase is different, we'll have the different frequencies. If the phase is same, we'll have the same frequencies. And this loop will, which it generates the DC signal. And here this RF signal, that is the reference block 1. So sorry, this is the reference block 1 and this is the reference block 2, and then which is given to the reference block of 3, and here what again we get the frequency of 4. This is the reference signal of 1, and then it feeds feedback signal is 2, and then this phase detector signal will consider as 3, and which is given to the again to this output of this loop will go to this filter of 4. So this is the mechanism of phase lock loop. In next block we'll discuss about the amplifier.